This is Bitnar Talks, the engineer takes on construction. Episode 28. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Document L, Conservation of Fuel and Power, Volume 2, Buildings Other Than Dwellings. Hi, and welcome to Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Thursday, the 5th of September 2024, so yet another fortnight release of the episode, but I'm here back with you with the 28th episode and information on Approved Document L, Conservation of Fuel and Power Volume 2, Buildings Other Than Dwellings. The last episode was the longest of them all so far, so I'll try to keep this one a bit slimmer. It has been another busy week and the weather out there is sort of going to the worse. Seems like the British summer started to shift towards September, which was nice last year, but it doesn't seem to be this year. As ever, before I go to covering the material of this episode, let's have a look at what was covered last week. In the last episode, I talked about the first volume of the Approved Document L, Conservation of Fuel and Power, dealing with dwellings. These are contained within 2L requirements and 19 additional regulations covered in 12 sections of the document. Section 1 describes the process for calculating the total energy performance of new dwellings using the Standard Assessment Procedure, SAP, with key metrics including target primary energy rate, emission rate and fabric energy efficiency rate. For buildings with multiple dwellings, these targets may be averaged based on floor area. Section 2 deals with the calculation of actual energy performance metrics, which must be compared to the target values described in Section 1, as designed and then after construction. These calculations are documented in the BREL report and submitted to Building Control with consideration for fabric efficiency and low carbon technologies. Section 3 requires a feasibility analysis of high efficiency alternative systems, such as renewable energy and heat pumps, before construction begins. This analysis must be documented and available for inspection regardless of whether the systems are implemented or not. Section 4 specifies limitations on heat gains and losses. It emphasizes U values and continuous insulation to prevent thermal bridging at the joints of thermal element planes. It sets minimum U values for new and existing dwellings with strict standards for renovations, ensuring airtightness and proper insulation. Section 5 mandates that new and replaced building services meet minimum efficiency standards and be correctly sized, with a focus on low temperature heating systems and appropriate controls. Existing buildings must also adhere to standards to prevent energy waste. Section 6 outlines performance standards for heating, cooling, ventilation and energy generation systems requiring high efficiency, appropriate controls and proper sizing as ever. It also covers district heating, underfloor heating and on-site electricity generation to ensure overall energy efficiency of the building. Section 7 mandates pressure testing for new dwellings to ensure compliance with air leakage regulations. Certified professionals must conduct this test with results submitted to building control and energy metrics recalculated based on the outcomes. Section 8 requires the commissioning of fixed building services and on-site electricity generation systems with a detailed commissioning plan submitted to building control. Compliance must be confirmed up to 30 days when we talk about the person who's registered as approved person scheme, or 5 days if we deal with build on notice or with the full plan's approval. We need to ensure the systems operate properly and meet standards, right? Section 9 requires that building owners receive clear, detailed information on the operation and maintenance of fixed services and on-site electricity generation systems upon completion. New buildings also need a BREL report and energy performance certificate with updates for significant changes in existing buildings. Section 10 mandates that new or replaced thermal elements in existing dwellings meet specified performance standards, particularly for major renovations or replacements. Extension and integrated conservatories must also adhere to these criteria, ensuring energy efficiency is maintained. Section 11 stipulates that buildings undergoing a material change of use, renovation or energy status change must comply with relevant energy efficiency and thermal performance standards. Major renovations must meet updated criteria with SAP procedures used for assessing energy use in multiple dwellings. Section 12 requires that work on existing buildings over 1,000 meters squared involving extensions, implementations of new services or increased service capacity comply with Part L requirements, provided it is feasible. Renewable energy installations are exempt with further guidance in Volume 2 of the approved document. In this episode, I will move to approved document L, Conservation of Fuel and Power Volume 2, Buildings Other than Dwellings. So without further ado, let's dive straight into this. In this episode, I'll talk about the statutory guidance contained within the approved document L, Conservation of Fuel and Power Part 2, or actually Volume 2, Buildings Other than Dwellings. The requirements L are short and sweet, and only 2, but that is further expanded by 17 different additional regulations, including Regulation 6, some regulations from Part 6 of the Building Regulation, as well as Part 8 and Part 9. These are basically the same requirements as with dwellings with slight differences. There are no regulations 26A and 27A included, so aspects concerned solely on dwellings are excluded. The episode will follow the structure of the approved document from Section 0 to Section 12 and all the additional regulations along the way as laid down in the document, but I will not return back to reading you the text of the legislation as this has already been done in the previous episode. I strongly recommend you listen to that episode as the philosophy and layout of the approach is very similar, and I trust it will help you to consolidate your knowledge about these requirements. So let's get into the nitty-gritty of this approved document. Alright guys, let us start with Section 0 then, which simply introduces us to the documents, stated what is included within it and its application. It overlaps heavily with Volume 1, but we will find differences like information on different provisions for the shell and core, first fit commercial buildings, and then afterwards considering second fit as work on the existing building. Modular builds will be treated as a new building, and if this technology is used for the extension work, the building may need an upgrade also. In general, work on new buildings is covered in Section 1 to 9, on existing buildings Section 4 to 6, and 10 to 12. Some buildings are exempt, like places of worship, temporarily buildings used for less than 2 years, low energy demand buildings, industrial sites, workshops, non-residential agricultural buildings, standalone buildings of up to 50 meters square useful floor area, aka gross floor area, carports, covered yards, covered ways, some conservatories and porches are also exempt. And the same rules apply as in the previous volume of this document. Similar provisions as previously are given to open extensions of buildings at the ground level and an area of less than 30 meters squared, as well as the live work units and the mixed use units. Some exemptions are also given to historic buildings, monuments, listed buildings and buildings in conservation areas. Upgrading of these buildings should apply within the reasonable intervention criteria, so will need to be judged on the particular merits. The guidance contained within this document needs to be approached holistically with other aspects of the building regulations, things like ventilation, transfer of moisture, condensation, noise transfer, airtightness, and so on. Moving to section 1, which covers calculations of target primary energy rate and target emission rate. These two energy rates apply to a so-called notional building, that is, of the size and volume of the proposed building, but using standardized fabric and services specifications. We can find the full properties in the National Calculation Methodology Modeling Guide, available at www.uk-ncm.org.uk. The target primary energy rate is stated in kilowatt hours per meter square per year, and the target emission rate is measured in kilograms of CO2 per meter square per year. The calculation should be made using the Simplified Building Energy Model, so-called SBEM, SBEM, or another approved software in line with the current policy version. The software tools like list can be found on the Department of Levelling Up Housing and Communities, DLUHC, and a version of the policy, approved methodology, or which one to use can be found in the National Calculation Methodology Modeling Guide. Now these rates will be compared with the outcome of the as designed and as built calculations, as was the case with dwellings. Nothing really changed here. We set the targets, we design for them, and then check if what we've built meets it. So simple as. Section 2 deals with the calculation of the building's primary energy rate and building emission rate that gets to be put against the target values. As previously, we should use the same tools for the calculation rates and do it as designed and as built. Whereas as built calculations should take in consideration what was actually put together on site and taking into account the measured air permeability of the building. Both target, design and as-built rates together with the specification need to be communicated to building control, and this will usually follow the output of the approved software that uses BRUKL report standards, that is Building Regulation UK Part report. Now, taking in consideration the source of fuel, the calculations for primary energy may become slightly more complicated when the systems can be fired by two fuels like biomass and gas, or biomass and fossil fuel, or else. In the first case, we need to do a weighted average of CO2 emission based on the use ratio. In the second, similarly, unless if the appliance is in the smoke control area, then the anthracite figure needs to be used. For other combinations, the higher CO2 use case should be used. Using district or community heat networks will require us to establish primary energy factors and CO2 emission factors suitable to that network. National Calculation Methodology Guide information will be helpful in this regard. The calculation should take into account the entire system, the annual average performance, heat recovery, all plants, losses, combined heat and power, or heat dumping. The calculation should consider the first 12 months of operation as a baseline for future increases or decreases in the system capacity. Combined heat and power or trigeneration scheme should use factors from the National Calculation Methodology Guide, Table 32. In the case of trigeneration, the energy used should be attributed to the use in line with the total output, meaning that is what is used to supply you with heat or its removal. In district networks, the calculation should follow the energy source that will be used till the end of 2027, so that any changes in future can be accounted for, and when the change comes, it needs to be operationally and legally sound, meaning have planning permission when needed and contracted, and the building control will need to see the proof of it. All that needs to be accompanied by a report by a suitably qualified person showing how the factors were arrived at. The document provides an equation for the calculation of the primary energy factor, which is basically the efficiency of the system minus the energy generated by the system divided by the useful heat in kilowatt hours. Similarly, with CO2 emission factor, but with the CO2 emission in the equations instead of the efficiency. We can reduce the design rates for energy and emissions if we intend to use enhanced management and control features for the heating system. It simply follows the increased efficiency of the system when it is well controlled. As we do not waste heat when it is not needed, or make the operation of the system better by controlling output in line with the actual requirement, we make the system more efficient. The adjustment factors for such are either 1% for achieving a power factor of between 90 and 95, or 2.5% when exceeding 0.95 and 5% with a total control system. The document lets us know that only following the minimum fabric element standards will not suffice to meet the primary energy target rate or the target emission rate, and that the approach will need to be combined with efficient building services and low and zero carbon technologies. Special considerations for the calculations of rates should be given to modular and portable buildings with a service life of over 2 years, swimming pools, shell and core developments, industrial sites, workshops and non-residential agricultural buildings, and buildings with low energy demand. So let's start with the modular and portable buildings. The ones that are in operation for more than 2 years, that is. Building regulations consider placing of a module on a new site as the construction of a new building, and distinguishing between modules placed on one site and those that jump from the site to site. The stationary ones should comply with the energy efficiency requirements, but should the elements, well, at least 70% of the elements be manufactured at some dates prior to the implementation of this consideration, the factors can be extended by up to 68% for elements manufactured before the 6th of April 2006. When it comes to the portable buildings or modules that jump sites, this need to abide by the energy efficiency requirements also. The calculations should be made once the building is constructed for the first time. For relocations where buildings then stay on site for less than 2 years, that initial calculation will suffice, but the target emission rate should be taken in consideration the use of electric resistance heating in considering national building specification. Similar, 70% of the shell used in the construction expectations are also applicable here, but the extension of factor can be as high as 103% for elements manufactured before the 6th of April 2006. Now, swimming pool basins are treated similarly to dwellings, and we need to consider the fabric of the pool enclosure for the area of the pool in our calculations. Shell and core developments, on the other hand, should prove that they will meet the target once the building is fitted out. The design stage rates apply here. The design should specify what systems are being installed or ought to be installed at the time of a fit-out. At the time of completion, we should assume to what extent the space will be conditioned, and that assumption needs to be carried out. The incoming occupier will need to then abide by this to demonstrate compliance, whether that with the heat management or lighting. A new energy certificate will be required for the fit-out work areas. Building logbook should be completed with the first fit-out work information. When we assess industrial sites, the National Calculation Methodology Modeling Guide may fail to recognize the feasibility of the project, in which case we may need to resort to in-depth evaluation. Now, buildings with low energy demands are considered if they need to be heated, but not to the level of typical buildings or in their entirety. Rates need calculations, but to different standards, which can be found in the NCMM guide. In such buildings, each service needs to meet energy efficiency standards, be appropriately insulated, but the opaque building fabric cannot be worse than 0.7 watt per meter square Kelvin. Partitioned off or zoned heated normally should meet normal standards. When such building changes use to a building of normal energy demand, such building may need improvement. Similarly, when the shell and core building of low energy use is fitted out to be of normal energy use, a normal standards will apply. Section 3 is similar to dwellings. It again considers high efficiency alternative systems for our buildings, where we should assess the technical, environmental and economic feasibility of such systems and make it into a report available to view by building control. Short and sweet. In section 4, which deals with the fabric performance regarding heat gains and losses, BRE report 443 is used for the assessment of elements and in the case of windows that consist of the glazing and frame altogether, treated as a controlled fitting. When it comes to windows, the document gives us options for it. We either go about it in detail or treat the window as standard and take size limits on board for windows in similar settings to dwellings. The limits are 1.23 meter width plus minus 25% and 1.48 meters height plus minus 25%. We then either treat it as a particular window configuration or use a standard configurations which relates to framing. The standard window configuration will not apply to commercial windows. Or alternatively, we can approach the matter using hotbox method to BSEN ISO 12567. When we deal with doors, we follow similar conditions, but the sizes are ever so different, and we deal with doors under 3.6 meters square and over 3.6 meters square, with standard sizes being 1.23 meters by 2.18 or 2 meters by 2.18 height. And again, plus minus 25% variation on each dimension. Hotbox method or using the actual size and configuration is fine also. Mind, there will be different limits depending on the plane of the element. Elements placed horizontally need to carry a better U value with them. Generally, all new elements, including that of the extensions or replacement in existing buildings, need to follow the set limits. If we are dealing with elements that we cannot change, we may need to add secondary elements to make it better, and the central pane of the component should not be worse than 1.2 watt per meter square Kelvin. Some of the U value limits are as follows. Roofs, if flat, are 0.18 and 0.16 otherwise. Walls 0.26 and floor 0.18. Swimming pool basins 0.25 and some more. All for the air permeability of less than 8 meter cubed per hour per meter square. Renovated elements will have slightly different limits, and the condition of the repair will also govern if we need to upgrade the thermal element or not. Similarly, with elements that are forming the enclosure of adapted or converted spaces, the change also depends on factors of reasonability like a 15-year payback time and technical or functional feasibility. Generally speaking, elements should not lose more than 0.7 watt of energy per meter square of 1 Kelvin degree difference, but less when considering elements in horizontal planes. The limiting factors for such improvements are the threshold and improvement U values. Threshold are 0.35 for roofs and 0.7 for all the rest, improving to 0.16 for ceiling level roof insulation and otherwise 0.18. Floor to 0.25 and walls either 0.55 for cavity insulation and 0.3 for external or internal insulation. It is important to maintain the continuity of the insulation and avoid breaks in it throughout. Avoid thermal bridging or to avoid air movement through the insulation layer. Thermal bridging can be established detail by detail using BR497 methodology or using typical values from BRE information paper 1/06, increased by 0.04 watt per meter Kelvin or by 50%, whichever is greater. In any case, the performance of the detail should exceed the minimum set in the information paper. Building control should be satisfied if all this is done by the competent person. It is demonstrated that the detail can be achieved on site, and the robust methodology of checking if it actually has been implemented correctly on site is in place. When we renovate or replace thermal elements, we need to make sure a suitable signed report is made to account for the change, confirming the suitable design details and building techniques have been specified and that the elements provide adequate protection from the surface condensation as identified by BRE publication 497 and information paper 1/06. We are reminded by the document to mind the airtightness of the building and to maintain good seal with newly installed or replaced elements. We should also mind the thermal gain, and new buildings are covered in the approved document O, about which an episode is coming, but otherwise let's try keep it to a reasonable level to let that aircon unit a chance. The consideration is for the usable space in which we generally operate, which is air conditioned. In such cases, the solar gain as treated from April to September should be considered and should not be greater than the relevant reference system with the solar energy transmittance, so-called G values, as calculated to BSEN 410. The limit values are as follows: 0.48 for side lid spaces at east face facades and top lid up to 6 meter height roof location, and 0.42 for roof location and zone height over 6 meter. The glazing area taken in consideration is a full width up to 1 meter height and for roof up to 10% of the roof area. Building services may also add considerable heat gain and losses. Hot water pipes should be always insulated unless we need that heat in the room. Insulation should follow BS 5422 standard, which for low heat pipes in hot water space heating systems means between 15 to 55 mm of thickness between the pipes of 10 to 100 mm diameter. For coating of thermal conductivity between 0.025 to 0.04 watts per meter Kelvin, and slightly less for hot water services. Temperature limits are 95 degrees Celsius and less for heating, and 60 degrees centigrade for the hot water. Cooling pipes should be also insulated unless the cooling load related to distribution pipes is less than 1%, meaning there will be minimal losses at such piping. The insulation should follow BS 5422 heat gain limits and the HVAC guidance of the manufacturer to mitigate condensation. Heating or cooling air ductwork should also be insulated with insulation thickness according to calculations made to BSEN ISO 12241. The document states certain specifications for ducts using certain assumptions like the size of the vertical sidewall and the nature of surrounding air and its temperature and thermal conductivity limit of insulated material. We are told to use 21 mm insulation for heat ducting and 36 mm for cooling and dual-purpose ducting. Hot water storage vessels heat loss should be limited to approved levels and energy consumption control to BSEN 89. According to the document, the rates should be within 2.1 to 5.2 kilowatt hours per 24 hours for storage vessels between 200 and 2000 liters. Now, services should be efficient, and that is covered in section 5 that deals with minimum building services, efficiencies and controls. The efficiency claimed should be tested to the appropriate test and certified by a notified body. Replacement fixed building services should be at least as good as the existing, but no worse than the value given in section 6. If the replacement service uses different fuel, we need to think about its CO2 emissions and primary energy demand. In both cases, the levels should be not worse than that of the existing system. Replacement of renewable technology should be like for like in terms of output. Every new heating appliance should be controlled in the matter of timing of operation, temperature, and when possible have a weather compensation installed. We should also consider possible connection to the district heat network system in future. Sizing new and replacement space heating systems should follow appropriate heat loss calculations for the building, which should be based on BSEN 12831-1 standard and CIBSE's Guide B1, making sure the systems are not significantly oversized. Wet heating system, when it is newly installed or fully replaced, including pipework, appliances and emitters, should be sized to 55 degrees Celsius or less flow temperature, or to as low temperature flow as is practical for a given heat source for the building. Naturally, control of the system is important, and zoning of the heating system and its control can fine-tune the operation. Zones should be considered by a solar exposure, pattern of use and type of use, and significantly different areas should be made into zones. Control of timing and temperature should be dependent for each zone. Heating and cooling of the given zone at the same time should be prevented by the system design, and the heating should have weather compensation whenever possible. The system should switch itself off whenever not needed. The system for heating and provision of domestic hot water should be cleaned and flushed out. Heating systems should be treated to inhibit scale and corrosion. Descaling of the feed water may also be necessary to prolong the service life of the system. All rooms where we need or indeed can control the temperature should be provided with thermostatic control. Building of low heat demand under 10 watt per meter square and buffer zones in buildings with high thermal mass may not need to be controlled in this way. In cases where it is better to control zones rather than rooms, do so. It's considered for open spaces. The zones are considered for open spaces or adjacent rooms of similar rooms. Heat recovery from exhaust air may be also controlled if technically and economically feasible. The control of the room or zone thermal condition will be either by a thermostat in the room and control of each emitter, thermostatic control of the room or zone, or individual network heating or cooling emitter control for each emitter. Sub-meters should be installed in new buildings with new heating system installations or the extensions. The sub-meters should inform us on the use of the particular fuel with 90% accuracy for the purpose. CIBSE's TM39 gives recommendations on how to achieve it. The information provided by the meter should be good enough to inform on our use and performance in contrast with the design stage energy forecast. It should allow to separate tenants and account for renewables. If the building is over 1,000 meters square, the whole meter reading and data collection should be automatic. Now we move to section 6, which gives us specific guidance on the efficiency of systems. We are straight up informed about the Eco-Design for Energy-Related Products Regulations 2010 and its requirements, and that we should also pay attention to it, as we do to this legislation. The equipment specified for the given building and its use should be selected to optimize its use in the given circumstance, and that's the gist of the whole thing. Now we go system by its type, starting with boilers. These are considered as part of a wet central heating system fired by commercial boilers using natural gas, LPG, oil or biomass. That is it. Now the efficiency requirements will be slightly different depending if the system is installed in a new building or the old one. For new buildings, single boiler up to 2 megawatts output should be 93% efficient, and the same is for multiple boilers. If the boiler output exceeds 2 megawatts, the efficiency can drop to 88%, as can for a single boiler in multiple boiler scenario. The efficiency is considered seasonal and take gross calorific value using natural gas. Systems in existing buildings can be slightly less efficient when it comes to natural gas use. In fact, they can be as low as 84% for single boiler over 2 megawatts output and 91% for small boilers and multiple boilers. Other fuel type efficiency should beat the standards set for the new buildings. We are also informed that whenever possible, we should think about fitting non-condensing boilers with a flue condensing kit. That is, whenever possible. The way we arrive at the seasonal efficiency for single boilers and multiple boiler systems with identical boilers is by given equation that divides the use of boiler into its gross efficiency working at 30% load and 100% load, and sum both of them in proportion of 81% to 19%. This equation applies to single boiler and multiple boiler systems supplying low temperature hot water of output up to 400 kilowatts. Boilers of the same efficiency. For boilers over 400 kilowatts, we should use manufacturers' declared efficiencies. The calculations for more varied systems is a bit more involved, but relatively as simple as the previous example. The stuff that I just mentioned about the combined efficiency at different levels of load, and if the boilers vary with their output and efficiency, we should weight their involvement by percentage of their output in the operation of the building. Boilers control on boilers over 100 kilowatts output should have optimum start and stop control with either night setback or frost protection outside occupied periods, and either a stage high-low firing facility in the boiler or multiple boilers with sequential control to provide part load performance. When the gas-fired and multi-stage oil-fired boilers exceed 500 kilowatts output, they should have fully modulating burner controls. For biomass boilers tested to BS-EN 12809, the efficiency should be no lower than 65% for gravity-fed system and under 20.5 kilowatts output, and 75% for automatic pellet or wood chip system. Gas and oil-fired warm air heaters, depending on how they deliver heat, they should be of at least 91% efficiency. They're regulated by the following standards: BS-EN 621, non-domestic gas-fired forced convection air heaters for space heating not exceeding a net heat input of 300 kilowatts without a fan to assist transportation of combustion air and or combustion products. BS-EN 1020, no domestic forced convection gas-fired air heaters for space heating not exceeding a net heat input of 300 kilowatts, incorporating a fan to assist transportation of combustion air or combustion products, which is now withdrawn. BS-EN 525, non-domestic direct gas-fired forced convection air heaters for space heating non exceeding a net heat input of 300 kilowatts. And BS-EN 13842, oil-fired forced convection air heaters, stationary and transportable for space heating. Woof! that was quite a series of Kalashnikov standards, one by one, in automatic round. Now, gas and oil-fired radiant heaters, if fluid, they should be tested to BS-EN 1020 or BS-EN 13842. The efficiency is a concern regarding the net calorific value and should exclude fans and take account of the radiant heater and pipe within the building envelope. The efficiencies, depending on the appliance type, will be somewhere in between 86 and 91% for thermal and over 55% for radiant heat generation. Electric space heating systems, these are considered to be 100% efficient. For boiler systems should have flow temperature control and be capable of modulating the power input to the primary water depending on space heating conditions, timing and temperature demand control, and heating controls split into zones for buildings over 150 meters square. For electric warm air heating, we need to think timing and temperature demand control as well as zoning. Radiant heaters should have automatic zone or occupancy presence detection. Panel heaters should have timing and temperature demand controls. Storage heaters should be also controlled by required input in line with the internal air temperature but with manual overdrive. Combined heat and power, so-called CHPs of capacity between 5 kilowatts and 5 megawatts used in commercial applications are covered here. Smaller installations should follow Volume 1 recommendations for dwellings. Such CHPs under annual operation should have a minimum CHPQA quality index of 105 and power efficiency greater than 20%. The plant should be metered, measure electricity generated and the fuel supplied to the CHP and controlled to ensure it operates as the lead heat generator. Dedicated domestic hot water heaters. These efficiency standards are applied to heat generator and any integral storage vessels, but not secondary pipework, fans, pumps, diverter valves, solenoids, actuators or supplementary storage vessels. The system should be sized and appropriate and based on BSEN 12831.3. The standards are generally over 91%, but over 92% for LPG fuel type. Either combustion heated or electrically heated domestic hot water system should be controlled. Time, temperature, flow control, emergency shut-off are just some of these controls. Now, comfort cooling. These recommendations do not apply to evaporative and desiccant cooling systems. Each cooling unit should meet the seasonal energy efficiency ratio SEER, which will depend on the type of the unit and its power. The cooling system specification should be based on heat gain calculation to CIBSE's Guide A and not be significantly oversized, meaning not bigger than 120% of the designed cooling load. As with all systems, cooling should also be controlled and divided depending on the needs of the particular space. Control of the cooling system should meet BSEN 15232 band C. We are provided with the formula for the calculation of SEER depending on the load condition and its efficiency ratio at the level of use at 25, 50, 75 and 100% load conditions. SEER should be determined using BSEN 14825. There are different variations for chillers depending on known or unknown parameters. Multiple chillers in a plant, systems with free cooling or heat recovery, variable refrigeration flow, absorption chillers using CHPs or district cooling schemes. Heating and cooling systems, circulators and water pumps. On variable volume systems, variable glandless circulators should be used. In case of a closed loop, if the water pump motor is rated more than 750 watts, it should be controlled by a variable speed controller on variable volume systems. Heat pumps, air-to-air heat pumps up to 12 kilowatts output should have either the seasonal coefficient of performance SCOP rating for a median temperature range of at least D to BSEN 14825, otherwise coefficient of performance COP of not less than 2.5 for space heating, 2 for hot water heating, 0.5 for absorption type heat pumps and 1 for gas engine. Any outdoor fans should be controlled and other heat sources should be incorporated into a single control mechanisms. Mechanical ventilation. There is many factors to take in consideration here. The bottom line is that we need to satisfy needs of the building and its occupation, but do it in a reasonable and controllable way and not to use energy when not needed. There are several standards referred to here, and these are BEAS DW-144 publication, specifications for sheet metal ductwork, BSEN 1507, ventilation for buildings, sheet metal air ducts with rectangular section, requirements for strength and leakage, BSEN 12237, ventilation for buildings, ductwork, strength and leakage of circular sheet metal ducts, BSEN 13403, ventilation for buildings, non-metallic ducts, ductwork made from insulation duct boards, BSEN 1886, ventilation for buildings, air handling units, mechanical performance, BSEN 16798-3, energy performance of buildings, ventilation for buildings, for non-residential buildings, performance requirements for ventilation and room conditioning systems, modules M5-1, M5-4, BS 8850, Fan coil unit performance, determination of specific fan power, test method. To establish limits on the specific fan power for a given scenario, so-called SPF in watts per liters second, we need to relate to the table provided in the document where we will find different values for new and existing buildings. The SFP value at 25% of the design flow rate should not be higher than that at 100%. Fans that are rated over 1100 watts should be fitted with variable speed drivers. Ductwork needs to be reasonably airtight, as should air handling units, which should comply with Class L2 to BSEN 1886 and so on. Heat recovery should be used whenever possible. When it comes to lighting, in the gist it needs to be enough for the space and activity. Design should be based on the CIBSE's SLL Lighting Handbook or similar design guide. General lighting should be at efficiency of 95 lumens per circuit watt or observe Lenny method, that's lighting energy numeric indicator. If it is display lighting, it's 80 lumens or up to 0.3 watt per meter square power use, or use Lenny method. For higher excitation purity light sources, we go down to 65 light source lumens. The lighting energy usage should be metered by either separating it into material circuits, meter coupled into the lighting system controller, or through lighting management system. We are directed to Bread Digest 498 for more information on lighting control. We are told to control lighting whenever possible, including switching off when space is not occupied or well lit during the day, and that the display lighting should be separated on a separate circuit. Building automation and control systems. These need to be installed when buildings' heating or air conditioning effective rated output is over 190 kilowatts. It is prudent to have the smaller installation controls too, but at least provide the minimum manual switch to switch the appliance off when not needed. The effective rated output basically includes all parts that use energy to condition the space, but does not include heating for emergencies, for frost protection, for domestic water, or for industrial processes. We shall account for the heat network delivery and capacity of the appliances when appropriate, and should account for the final stage of the building use. Building automation and control system specification should comply with BSEN ISO 16484, and it should continuously monitor, log, analyze, and allow for adjustment of energy use. The monitoring of energy efficiency should be automatically capable of detecting losses, benchmarking performance, and informing the responsible person about opportunities for improvement. It should be capable of bringing all building systems together under one control, no matter the type, manufacturer, or model of the system or appliance. We are told that the Class A control system to BSEN 15232 meets the requirements. But as ever, this should be appropriate to the building, expected usage, and service specification. On-site electricity generation and storage, on the other hand, in such systems should be appropriately sized for the need, and when replaced should not be smaller than what's needed. The system should be fully automatically controlled. District heat networks and community heating. In such case, the heat source should comply with minimum standards and should not have greater emission than 0.35 kilograms of CO2 per kilowatt for the heat delivered to a new building and checked against the building emission rate. Moving on to section 7, which deals with permeability and pressure testing. So the minimum standard for air permeability is 8 meters cubed per hour per meter square at 50 pascals, and we need to prove our building is sealed enough to achieve or exceed this target. We need to prove the building control that the test was done properly, using well-calibrated machinery and by appropriate personnel. This means the manufacturer or UCAS accredited calibration usually every 12 months, but at least every 24, and in accordance with CIBSE's TM23. The person doing the testing also needs to be trained and registered to test the specific class of building. Certain buildings do not need testing, taken conditions are met, like building under 500 meters square total useful floor area if air permeability used to calculate building primary energy rate and building emission rate is taken as 50 meter cube per hour per meter square. The building is factory made modular construction under 500 meters square is to be used for more than 2 years in general, and modules are linked using standard details. The base data for this particular unit should have been established in situ previously, so you can do it, but with caveats. For large extension, if it is not particular to seal it off from the main building, we may need to treat it as a complex building. In the case of complex buildings, where testing may not be practical, we need to justify how that is and how we to achieve a continuous air barrier in our building. The justification and strategy for the air barrier may suffice for building control purposes. TM23 publication is the point of guidance, and we should not try to push the claimed air permeability to values lower than 5 m3 per hour per meter square at 50 pascals. For compartmented buildings, it may be sufficient to test a representative area only. The building emission rate and primary energy rate need to hit the target, and they need to be rechecked following the testing to ensure such is the case. If the building fails the test, we need to improve it, and the record of all tests need to go to building control. The procedure for testing is approved and contained within CIBSE's TM23 publication. Section 8 deals with commissioning. So we are told that fixed building services need commissioning to make sure they are fit for purpose, meaning fuel and power is not wasted, energy generation is reasonable for the circumstances. It means testing and adjusting to meet the needs. For large and complex projects, a commissioning manager should be appointed, and his skill set and knowledge should fit the CIBSE's Commissioning Code M requirements. We are told that if we install a system that is subject to energy efficiency requirements, a commissioning plan needs to be made that will address the following: the system to test, tests to complete, schedule of commissioning, roles and responsibilities, and documentation requirements. The building control will need to receive the commission plan, the target, and the building energy and emission rate, and will keep an eye on the commissioning as the build progresses. Commissioning should follow CIBSE's Commissioning Code M, either or a combination of specific CIBSE commissioning codes or BSRIA commissioning guides that relate to a particular service and the procedure of leakage testing of ductwork. Notice of completion needs to be given to building control and the owner, confirming that the commissioning plan was followed, that all systems have been inspected in appropriate sequence to a reasonable standard, and to confirm it is as intended, but comment on any shortcomings where they do not perform as well as they should. The period for the notification is 5 days after completion, but can be up to 30 days for the person commissioning the work being registered in the competent person scheme. Now, about the air leakage testing of ductwork. If the system is served by fans with the design flow rate over 1 m3 per second, the leakage test should be carried out to Building and Engineering Services Association, BESA documents DW/143 and DW142. If we test randomly at least 10% of low pressure ductwork to DW143, we can calculate an improvement on building rates in line with the National Calculation Methodology Modeling Guide. The document recognizes BESA Specialist Ductwork Group or ADCAS, ATCAS, the Association of Ductwork Contractors and Allied Services, as competent organizations, so the members will be considered such too. The leakage limits are given, and if the ductwork fails them, we will need to improve it and test some more. The limits are different depending on the class of the ductwork, from low to high pressure classes A to D, a limit of maximum positive and negative pressure and maximum air velocity, and is given in liters per second meter squared. Section 9 tells us what information we need to provide. We talk here about building logbook, which should follow CIBSE's TM31 publication, and it is where the operating and maintenance instructions should find their home in the owner's hands. It can relate to maintenance manuals or the health and safety file. We are directed to seek further information in BSRIA's BG 26/2011 publication. Tank breaker. The information provided should allow for the energy efficient operation of the building. So information about the building, fixed building services and on-site electricity generation and the maintenance requirements of the fixed building services and on-site electricity generation, as well as the copy of complete commissioning records. Large buildings, meaning over 1,000 meters squared, will need a detailed assessment or forecast, if you like, of their energy use per fuel, determined by using a combination of design calculations, energy benchmarks, and energy forecasting methodologies such as CIBSE, TM54, or other building modeling or spreadsheet tools. SBEM output is considered not compliant with forecasting estimates. The logbook should also contain the target and building energy and emission rates and the information for the building automation and control system when installed. For work on existing buildings, the existing or new logbook should also contain the following: information on the thermal elements but existing, controlled fitting but existing, and any newly installed energy meters. The efficiency of new services or the entire system should be assessed and recorded. For new system, we will need to quantify the change by either assessment to generate the energy performance certificate, eco-design labeling, and documentation as appropriate. A documented assessment of a reasonable representation of the complete system by the manufacturer or by other equivalent assessment method used by qualified person. Technical information should be given to the owner when changing elements of the system, like boiler or emitter. The information following the fit-out should be also provided in the logbook, as should work that extends the capacity of the system by more than 25% or fundamentally alters its parameters. Section 10 treats on new elements in existing buildings, including extensions. In the gist, the new elements should be up to current expectations unless the new elements do not form a part of the thermal envelope of the building and do not rely on the building's heating system. We are directed to Section 4, Paragraph 4.5, 4.6 and Table 4.1 for limits of fabric performance. The proof of the window energy rating may be from a certification scheme that follows calculation and quality assurance. Enlargements of openings should be also within limits to avoid the requirement of general improvement to compensate for that opening. The limits are either 20% of the area of the roof for roof lights, 30% for exposed walls in residential buildings, 40% in assembly, offices and shops, and 15% in industrial buildings for windows and doors. There are limits for an extension. If we extend the building that is over 1,000 meters square, we need to consider consequential improvements, and if the extension is larger than 100 meters square and greater than 25% of the useful floor area of the building, we need to consider the extension as a new build. The openings in the extension should follow the limits as mentioned for openings enlargements. However, while access doors, display windows and similar glazing and smoke vents can be as large an area as required for the purpose. We can also area weight the U values to compare with the extension value that complies with the requirements to prove compliance, or we can use calculation tools to apply it to the existing building plus notional extension and compare it with the proposal. Conservations and porches are treated in the same way as the domestic counterparts are. Section 11 deals with work to fabric elements in existing buildings. This section gives us directions when we renovate existing thermal elements, make the material change of use of the building, or make changes to the building that constitutes a change to energy status. If we add new or replace elements, we should follow the directions of the previous section. By renovation of the thermal element, we mean the addition or replacement of a layer externally or internally, replacement of waterproof membrane on a flat roof, or providing cavity wall installation. Now, if we improve more than 50% of the surface area of the element, we should improve the entire element to appropriate limits of Table 4.2, Column B. Similarly, if at least 25% of the building envelope is being renovated, we shall upgrade it. In the case of the material change of use, we need to think about the change of the energy use due to its operation and it similarly follows to other aspects of building use too. The considerations are simple. Whenever the energy use has changed, we need to upgrade that part of the building to maintain or rather improve its energy performance. The assessment then generally follows the procedure of establishing the existing new value of the element and comparison with limits and applying the specification to reach a target when necessary. These are included in section 4. U values for windows and doors in such case are limited to values under 3.8 watts per meter square Kelvin for roof lights and 3.3 watts per meter square Kelvin otherwise. New and replacement elements shall be treated as much as such, meeting standards for new and replaced elements. The total area of openings in newly created buildings should not exceed 25% of the total floor area unless otherwise proven that the building can otherwise meet the energy performance despite a higher percentage of openings. Then section 12 tells us about consequential improvement, the improvement to large buildings. This type of improvement may be necessary when we deal with a building that is over 1000 meters square of useful floor area and we wish to extend it, provide fixed building services within it for the first time, or increase the capacity of the building system, which is not to come from renewable technologies. Improving building energy performance as part of principal works is considered consequential improvement, but if we improve the building on account of justify an extension of poorer quality, then this is not considered a consequential improvement. So when we extend the building that's over 1k meters squared, or the habitable area is being increased, we need to think about consequential improvements for at least the extent identified in Appendix D of the approved document. Table D1 shows what is considered technically, functionally and economically feasible in typical circumstances. We are also hit with a minimum spend on the work, which is at least 10% of the cost of the principal works, and that numbers need to be established by a chartered quantity surveyor or other qualified person forming part of the building control submission. Now, when we install the fixed system or extend the existing one, increasing the capacity per meter square, we should do the same as what we need for extension, so at least upgrade to table D standards of 10% principal works value and report that value to building control and improve serviced area to these standards no matter the cost of the principal works. There is some important information hidden in the appendices, things like key terms, but also lighting energy numeric indicator method of calculation to arrive at the appropriate level of energy used per square meter per year used by the lighting system, BRUKL report requirements, further information and standards for consequential improvement of the heating systems when required, and how to establish the seasonal efficiency of the existing heating system when the parameters are unknown. So this is it, folks. The approved document L, Conservation of Fuel and Power Volume 2, Buildings Other than Dwellings. Let's sum it up section by section. Section 0. The introduction highlights the overlap with Volume 1, noting differences in provisions for various building types and the stages like shell and core, modular builds, second fit out. It also details exemptions for certain buildings and stresses the holistic approach to integrating the document with other building regulations. Section 1 focuses on calculating the target primary energy rate and emission rate for a notional building using standard specifications. The calculations performed using approved software like SBEM must be compared with the as designed and as built rates, with results communicated to building control. Section 2 discusses calculating the building's primary energy rate and emission rate, emphasizing the importance of accurate as-built calculations, especially when multiple fuel sources are involved. The section also addresses special considerations for district heating system and potential adjustments for enhanced system management. Section 3. This section tells us that we need to assess high-efficiency alternative systems for our buildings, requiring a report on their technical, environmental and economic feasibility for building control insight. Section 4, it covers fabric performance related to heat gains and losses, outlining specific U-value limits for different building elements. The section also addresses the importance of thermal bridging, airtightness and controlling solar gains in new buildings, with particular attention to service insulation and heat loss prevention. Section 5, this section establishes the minimum efficiency standards for building services, requiring compliance with specific standards and testing for new and replacement systems. We are informed to assure proper sizing, control and maintenance of heating systems, including the use of meters for accurate energy monitoring and reporting. Section 6. This section outlines the energy efficiency requirements for various building systems, including boilers, heaters, heat pumps, mechanical ventilation efficiency standards, vary depending on the fuel type and system capacity, with additional guidelines for control system and specific technologies like combined heat and power, as well as lighting. Section 7 is all about air permeability standards, which are set at 8 meter cube per hour per meter squared, 50 pascals, with specific guidelines on testing procedures and exemptions. Testing must be conducted by qualified personnel using calibrated equipment. Extensions and complex buildings have tailored requirements, and all results must be reported to building control. Section 8 deals with fixed building services that must be commissioned to ensure energy efficient operation. A commissioning plan is required for systems subject to energy efficiency standards, and all commissioning activities should align with CIBSE's Commissioning Code M. A notification of completion must be submitted to building control, detailing the commissioning outcomes and any deviations from expected performance. Section 9 tells us that we need to inform people of what has been done to building. A building logbook following CIBSE's TM31 must be provided, containing details about energy efficient operations, maintenance requirements and commissioning records. Large buildings over 1,000 meters squared require energy use forecasts. Updates to the logbook are necessary when systems are modified, ensuring all changes are documented for continued compliance. Section 10 deals with new elements in existing buildings. New elements added to existing buildings must meet current energy performance standards unless exempt. Extensions over 100 meters square may need to be treated as new builds, and specific limits apply to glazing and other elements. Compliance can be demonstrated through area-weighted U-values or approved calculation tools. Section 11. Fabric elements in existing buildings, renovations or material changes to the building's fabric that affect energy use must improve the thermal performance to meet specific U-values. Significant renovations, such as more than 50% of an element's surface area, require upgrades to the entire element. Section 12. Consequential improvements. For buildings over 1,000 meters squared undergoing extension or significant system upgrades, consequential improvements are required to enhance overall energy performance. These improvements must be technically, functionally, and economically feasible, with a minimum spend of 10% of the principal works costs. In the next episode, we will move to approved document M, Access to and Use of Buildings, Volume 1, Dwellings. I hope you enjoyed this episode and that the consideration of the approved document L, Conservation of Fuel and Power Volume 2, Buildings Other than Dwellings, are clear for you now. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. In Bytna, we deal with planning, designing and managing of your projects, and we are always glad to facilitate a free initial consultation to steer you in the right direction. Visit www.bytnar.co.uk and reach out to us. Whether your question is if we can help you with your project or what should I do, we will be able to give you a piece of non-obligatory advice. At Bytnar, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigate the reasons behind it and to provide you with an appropriate strategy, design and specifications for the repair. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. See you next week. Bytna designs the world around you. Toodaloo.